Hello class, this is Dr. Viv again. This will be a continuation of the video on cross products. I taught you how to do cross products using the basic definition of the cross product and the anti-commutative arithmetic method in the previous video. And in this video I'm going to show you the third method, possibly the most commonly used method by engineers, and this is called the determinant method. The knowledge of this method requires a little information on what a matrix is and what a determinant is, but I'll just tell it to you in a very operational fashion. So last time in the previous video I had to evaluate the cross product of two vectors, and the vector A I chose to be in the previous video 5i hat minus 2j hat plus k hat, and the vector B was given by 6i hat plus 0j hat, meaning it does not have any j hat component, minus 3k hat. And we were supposed to find the cross product. Just for reference, let me copy down the result I got from the second method. I got the answer to be 6i hat plus 21j hat plus 12k hat, and we're going to try to get the same answer using the method of determinants. So the determinant of a matrix is defined like this. If I have so I'm going to write the cross product as a determinant, and the instructions to do that are to put I hat, j hat, and k hat on the top, put the x component, the y component, and the z component of A without the I hat, j hat, and k hat. You just put the numbers that appear multiplying them. Similarly for B, you put the components. So this has to be now evaluated. How do you evaluate this? First, there is a rule, and that's called the assignment of signs. You've got to put signs in front of A, B, these three things. The rule is that we put plus sign here, a minus sign there, and a plus sign there. Now if you're wondering why that kind of rule is there, it has to do with the method that mathematicians assign when they're evaluating the determinant. The determinant, by the way, is indicated by two vertical braces that you put across these two things. So the sign is given by the sign convention of minus 1 to the power row number plus column number. So the row number here is, let's do a few. That's minus 1 to the power for row number 1, column number 1. So that's going to be plus. This is going to be minus 1. That's called a row, and that's called a column. So that's the row, and that's a column. Oh, actually, I did it the opposite. That's the column, and that's the row. So this is going to be row number, j hat's going to be row number 1, column number 2, 1 plus 2 is 3, and negative 1 to the third power is just negative. And let's do the last one. Row number 1, column number 3, so that's going to be negative 1 to the power 4, which is plus. And you can go around assigning the signs for all the remaining ones, but I'm not going to do that. I'm going to choose to expand it from the top row. You can expand the determinant many ways. You can expand it through columns, you can expand them through diagonals. There are all kinds of interesting ways of expanding a determinant, but I'll be doing the most straightforward and perhaps boring way of expanding a determinant. So what I'll do is, the first step in expanding a determinant is to write down I hat, j hat, and k hat. So this is, by the way, this is going to be our cross product C. So that's going to be equal to, I'll do a vertical equals, it's going to be equal to I hat plus I hat, because of the plus sign there, times a 2 by 2 determinant. That's a 3 by 3 determinant, meaning it has three rows and 3 columns. Now this is going to be a 2 by 2 determinant. I'll tell you in a moment how to do that, but let me first write down everything else. Minus j hat, because of the minus sign in front of due to this convention, times another 2 by 2 determinant, and the last one is plus k hat times another 2 by 2 determinant. Now the determinants that you put here that are 2 by 2s are got by the following rule. If you're looking at I hat, you are going to pivot about I hat. So if you're familiar with chess, I hat should be thought of as the rook or the castle. The castle controls all the elements in this row and in this column. They can all be attacked by the rook, leaving us with just these 4 elements that survive. So write down those 4 things that survive under the I hat determinant. Now when you do j hat, you play the same game. Think of j hat as the rook, so that kills everything except 5, 1, 6, and minus 3. The last one is k hat, so that's going to be 5, negative 2, 6, and 0. Now here you can play the same game of assigning signs to each of the elements. That's going to be negative 1 to the power 1 plus 1, or plus, and that's going to be minus. Same way here, plus, minus, and then you're going to expand it further. So this is still our vector C. So our vector C will now be equal to I hat, and now I'm going to write this as plus negative 2, which is negative 2, times, you have this, okay, now you just have minus 3 left, and that's just a simple number, plus, and that's negative 1, and what you have here is 0. And you do the same thing for the remaining 2. Plus minus 1 times 6. K hat. Plus 5 times 0. Plus, now be careful, that's minus ahead of minus 2, so that's minus of minus 2, which is plus 2 times 6. Now let's calculate the total. That's 2 times 3, which is 6 I hat, and that's going to be negative j hat times 5 times minus 3, which is negative 15 minus 6, plus k hat times 5 times 0 is 0, and that's 6 times 2, 12. You see that it actually comes out exactly equal to what we had before, 6 I hat. This is negative 21, but there's a negative outside, so that's positive 21 j hat plus 12 k hat. In this way, we see that the second and the third methods of evaluating the determinant, the antisymmetric circle method and the determinant method give us exactly the same answers. The first method is the weakest by far. It only gives us the magnitude, and the direction you just have to say it's my thumb. And if someone says, well, where's your thumb pointing, you can't really do much. But the second and third methods are really where the money is in terms of evaluating a determinant. So you can pick your favorites among methods 2 and 3 to evaluate your determinant. For a simple problem with only a couple of components that are not zero, I would actually go with the earlier method 2. But in the complicated problem where you have I, j, and k components, it's best to always use the determinant because it's a straightforward procedure and gives you the answer in a few steps. In your formula sheet for this course, we only teach you the determinant method, and we also write the basic definition in terms of AB sine theta. We don't teach you the method 2, although I think the method 2 is almost easiest of the 3 methods. So feel free to use whichever method you feel like using for the determinant. It's better to always have more methods than fewer methods.